You want to be teleported? Of course you do. We all do. The idea is intoxicating, isn't it? Step into a machine in London, step out in Sydney moments later. No airports, no queues, no 14 hours crammed into an aluminium tube breathing recycled air while the person next to you snores. Just instant travel, here, then there. The universe shrunk to the size of a single step. Science fiction has promised us this for generations. Captain Kirk dematerializes on the Enterprise and rematerializes on some alien planet, usually just in time to kiss an alien or punch a villain. The fly merges grotesquely with a man in a telepod, teaching us to be careful with our insects. Harry Potter apparates from one place to another with a crack and a twist, making it look as natural as walking through a door. The technology varies, the special effects improve, but the principle remains beautifully simple. Take a person apart here, put them back together there. It sounds wonderful. It would transform human civilization in ways we can barely imagine. Cities would become irrelevant because you could live anywhere and work anywhere. Distance would lose its meaning entirely. The entire planet would become a single neighborhood where you could pop over to Tokyo for lunch and be back in Manchester for tea. Wars over territory might cease because territory itself would become meaningless. The economy would be revolutionized, human relationships would be transformed. And it is almost certainly impossible, not just difficult, not just beyond our current technology, not just awaiting some clever engineering breakthrough that will arrive in 50 years or 500. Impossible in principle, forbidden by the deepest laws of physics, prevented by the very nature of matter and information and what it means to be you. Tonight, I want to explain why. I want to take you on a journey into the heart of quantum mechanics, into the strange world where particles behave like waves and observation changes reality and nothing is quite what it seems. I want to show you what teleportation would actually require, what it would actually mean to take a human being apart and put them back together again. And I want to reveal the profound philosophical problem that lurks at the center of the dream, a problem so disturbing that even if teleportation were technically possible, you might not want to use it. You might step back from the machine and choose the 14-hour flight instead. Let me begin with what you are, because that is where the problem starts. That is where everything starts. You think of yourself as a single, unified thing, a person, a body, a self. You have a name that people call you. You have a history that you remember. You have a continuous experience of being you that stretches back to your earliest memories and will continue, you assume, until the day you die. You woke up this morning as the same person who went to sleep last night. You will wake up tomorrow as the same person who goes to sleep tonight. There is a thread of identity that runs through your life, connecting the infant you were to the child you became, to the teenager you endured, to the adult you are, to the elderly person you may, if you are fortunate, become. This sense of continuity feels absolutely real. It is, in many ways, the most real thing you know. Everything else might be illusion. The world outside your head might be a dream or a simulation or a trick played by a malevolent demon, as Descartes once worried. But surely you exist. Surely there is something it is like to be you, something that persists through time, something that is undeniably, irreducibly, absolutely you. But what is this you, physically speaking? What are you actually made of? What is the stuff of which you are composed? The answer is atoms, about 7 octillion of them. That's a 7 followed by 27 zeros. 7 billion atoms, give or take. Mostly hydrogen, oxygen, carbon, and nitrogen, with smaller amounts of calcium, phosphorus, potassium, sulfur, sodium, chlorine, and traces of many other elements. These atoms are arranged in extraordinarily complex patterns, forming molecules, forming cells, forming tissues, forming organs, forming systems, forming you. Here is the first remarkable thing, the thing that should give you pause. These atoms are not special. There is nothing unique or magical about the particular atoms that happen to compose you at this moment. The carbon atoms in your body are identical to the carbon atoms in a lump of coal or a diamond or the graphite in a pencil. The oxygen atoms in your lungs are identical to the oxygen atoms in the air around you, or the water in the ocean, or the rust on an old bicycle. The hydrogen atoms in your cells are identical to the hydrogen atoms in the sun, forged in the Big Bang itself, the most common element in the universe. There is nothing mystical about the matter that composes you. It is ordinary matter, the same matter that makes up everything else in the universe. The atoms in your body have been recycled countless times. They were forged in ancient stars that exploded billions of years ago. They have been part of rocks and rivers and dinosaurs and trees. They have drifted through space and fallen to Earth and been eaten and excreted and breathed and absorbed by countless organisms before they found their way into you. And after you die, they will continue their journey, becoming part of the soil and the air and eventually other living things. You are, in a very real sense, rented atoms, borrowed matter, a temporary arrangement of stuff that has existed for billions of years and will exist for billions more. What makes you different from a rock or a puddle of water or a cloud of gas is not the atoms themselves, but their arrangement, the pattern, the information encoded in how those 7 octillion atoms are organized, the way they are connected to each other, the structures they form, the relationships between them. This information is staggeringly, almost incomprehensibly complex. Let me try to give you a sense of the scale. Your DNA alone contains about 3 billion base pairs, 3 billion letters in the genetic alphabet, spelling out the instructions for building and maintaining you. This encodes roughly 20,000 genes, each one a recipe for a protein, each protein a molecular machine performing specific functions in your cells. Uncoiled, the DNA in a single cell would stretch about 2 meters. The DNA in all your cells, laid end to end, would reach from here to the sun and back several hundred times. But DNA is just the beginning. DNA is the blueprint, but you are not just a blueprint. You are a living, functioning, thinking being. And the information that makes you extends far beyond your genetic code. Your brain contains approximately 86 billion neurons. 86 billion nerve cells, each one a biological computer of astonishing sophistication. Each neuron is connected to thousands of others through synapses, the junctions where signals pass from one cell to another. The total number of synaptic connections in your brain is estimated at 100 trillion. That's more connections than there are stars in the Milky Way galaxy. The pattern of these connections, which neurons are linked to which others, is called your connectome. It is unique to you. It was shaped by your genes and your experiences, by everything you have learned and felt and done since you were born. Your memories are encoded in this pattern. Your personality resides in this pattern. Your skills, your habits, your quirks, your fears, your loves, everything that makes you distinctively you is written in the connections between your neurons. But even the connectome is not the whole story. The strength of each synaptic connection matters. The distribution of neurotransmitters matters. The precise electrochemical state of each neuron at each moment matters. The positions of proteins within cells matter. The conformations of molecules matter. The quantum states of individual particles matter. If we wanted to teleport you, we would need to capture all of this information. Every atom, every molecule, every connection, every quantum state. The position and momentum of every particle, to the extent that the laws of physics allow, the complete blueprint of you, in sufficient detail to reconstruct you exactly, down to the last quark and electron. How much information is this? Estimates vary depending on what level of detail you consider necessary, but conservative calculations suggest that the quantum state of a human body contains on the order of 10 to the power of 45 bits of information. Let me try to make that number meaningful. 10 to the 45 is 1 followed by 45 zeros. It is a number so large that writing it out in full would fill pages. It is more information than all the data humanity has ever generated by many, many orders of magnitude. All the books ever written, all the photographs ever taken, all the videos ever recorded, all the emails ever sent, all the data in all the computers and servers and storage devices on Earth. All of it together is a rounding error compared to the information content of a single human body. Could we ever store this much information? Could we ever transmit it? Could we ever process it? Consider our current technology. The total data storage capacity of the entire world is measured in zettabytes. A zettabyte is 10 to the 21 bytes. The information content of a human body is at least 10 to the 45 bits, which is roughly 10 to the 44 bytes. That's a difference of 23 orders of magnitude. We would need to increase global storage capacity by a factor of 100 billion trillion just to store one person. The fastest data transmission rates we have achieved are measured in terabits per second. At these rates, transmitting the quantum state of a human body would take longer than the current age of the universe. Not years, not millions of years, not billions of years, longer than the 13.8 billion years since the Big Bang, by a lot. These are not challenges that will be overcome by incremental improvements in technology. These are not problems that Moore's law will solve in a few decades. These are fundamental barriers, walls so high that we cannot see the top, chasms so wide that we cannot see the other side. But let us set aside the practical difficulties for a moment. Let us engage in a thought experiment. Let us imagine that we have somehow solved the storage problem, the transmission problem, the bandwidth problem, all of it. Let us imagine that we have found some revolutionary technology that allows us to record, store, transmit, and process the complete quantum state of a human body. Let us imagine that we have a perfect blueprint of you, encoded in some vast database, ready to be sent across the world or across the cosmos at the speed of light. What then? Here is where we encounter the first fundamental problem. Not a practical problem, a problem with the laws of physics themselves, the problem of measurement. To create this blueprint, we must measure the state of every particle in your body. We must determine where each atom is and how it is moving. We must capture the quantum state of every electron, every proton, every neutron. We must extract with perfect precision all the information that makes you you. But quantum mechanics tells us something disturbing about measurement, something that goes against everything our intuition tells us about the world, something that took the greatest physicists of the 20th century years to accept. Measurement is not a passive process. Measurement changes the thing being measured, and not in a subtle way, in a fundamental, irreversible way. This is connected to the famous Heisenberg uncertainty principle, but it goes deeper than the popular understanding suggests. It is not merely that we cannot know both the position and momentum of a particle with perfect precision. It is not merely a limitation on our knowledge. It is a statement about reality itself. Before measurement, a quantum particle does not have a definite position. It does not have a definite momentum. It exists in a superposition of possible states, a ghostly cloud of probabilities spread across space. The particle is not at any particular location. It is, in some strange sense, at all possible locations simultaneously, each with a certain probability. Measurement forces the particle to choose. Measurement collapses the superposition into a single definite state. The ghostly cloud condenses into a point. The particle suddenly is somewhere specific. And here is the crucial thing. We cannot know in advance which state it will collapse into. There is genuine randomness at the heart of quantum mechanics, randomness that cannot be eliminated by better technology or more careful measurement or more complete information. God, as Einstein complained, does play dice with the universe. What does this mean for teleportation? It means that the act of scanning your body, of extracting the information needed to recreate you, would destroy the quantum states we are trying to copy. We cannot gently read the information without disturbing it. We cannot peek at the quantum state without changing it. Measurement is inherently destructive. To teleport you, we would have to destroy you. Perhaps you think this is not a problem. Perhaps you think that as long as you are recreated elsewhere, it does not matter if the original is destroyed. The copy is you. The continuity is preserved. The thread of identity continues unbroken. You step into the machine in London, the machine disassembles you, and you step out in Sydney. What happens in between is just a technical detail. But is it? Is what emerges in Sydney really you? Or is it something else? Something that thinks it is you? Something that has all your memories and all your personality, but is nonetheless a different entity entirely? This is where the philosophical nightmare begins. And I want you to understand that this is not a minor quibble, not a semantic game, not an abstract philosophical puzzle with no real-world implications. This is a question about whether teleportation would be travel or murder, whether stepping into a teleporter would be the beginning of a journey or the end of your existence. Let me pose the problem starkly. Suppose we scan your body, extracting the complete quantum state of every particle. This process, as I've explained, necessarily destroys the original. Your atoms are scattered, your pattern is erased, the physical structure that was you ceases to exist. The information is transmitted to Sydney, where a machine assembles new atoms into the same pattern. A person emerges. This person has your face, your body, your fingerprints, your DNA. This person has all your memories, from your first day at school to what you had for breakfast this morning. This person has your personality, your habits, your fears, your loves, your sense of humor. This person feels exactly like you. This person is absolutely convinced that they are you. From this person's perspective, nothing unusual has happened. They remember stepping into the teleporter in London. They remember the brief moment of unconsciousness, or perhaps not even that. And now they are in Sydney. Success. Teleportation works. But wait, what actually happened? In London, a person was destroyed. Their atoms were scattered to the wind. Their brain, with all its delicate connections, was dismantled. Their heart stopped beating. Their consciousness ceased. By any reasonable definition, that person died. In Sydney, a new person was created. New atoms, freshly assembled, arranged in a pattern copied from the person who died in London. This new person never existed before this moment. They were manufactured, built, constructed from raw materials according to a blueprint. The person in Sydney is not the person who stepped into the teleporter in London. They are a copy, a replica, a duplicate. They think they are the original, but they are not. The original is dead. This is not a technical limitation that better technology might overcome. This is inherent in the very concept of teleportation by scanning and reconstruction. You cannot move a person by copying them. You can only destroy the original and create a duplicate. And a duplicate, however perfect, is not the original. You might object to this reasoning. You might say that I am placing too much importance on the particular atoms that make up your body. After all, atoms are fungible. One carbon atom is exactly like another. There is no physical difference between the carbon atoms in your body and the carbon atoms in any other object. Why should it matter if you are rebuilt from different atoms as long as the pattern is preserved? This is a reasonable objection, and it leads us to a deeper question. What makes you you? Is it the atoms or is it the pattern? Let me tell you something that might surprise you. The atoms in your body are constantly being replaced. You are not made of the same matter you were made of 10 years ago. Through the ordinary processes of metabolism, you take in new atoms from the food you eat and the air you breathe, and you excrete old atoms in your waste and your breath. Over the course of about 7 to 10 years, nearly every atom in your body is replaced. You are a pattern that persists through a constant flow of matter. You are like a wave in the ocean, a shape that maintains itself while the water that composes it is constantly changing. You are like a flame, a process rather than a thing, a dynamic pattern sustained by continuous exchange with the environment. If gradual replacement of atoms preserves identity, why should instantaneous replacement be any different? If you are the same person after 10 years of gradual atomic turnover, why would you not be the same person after instantaneous atomic replacement via teleportation? This is a powerful argument, and I do not dismiss it lightly. But I think it misses something crucial. It misses the importance of continuity. When your atoms are gradually replaced through metabolism, there is never a moment when you cease to exist. The pattern is continuously maintained. The old atoms are replaced one by one, or small group by small group, while the overall structure persists. Your brain keeps functioning. Your consciousness continues uninterrupted. The thread of experience is never broken. Teleportation is different. In teleportation, there is a gap, a discontinuity, a moment when the original pattern is destroyed and the copy does not yet exist. During this moment, however brief, you are not anywhere. You do not exist. Your consciousness has ceased. The thread has been cut. And then a new thread begins. A new consciousness awakens. A new person opens their eyes and believes themselves to be you. But is this continuation or is it replacement? Let me offer a thought experiment that clarifies the issue. Suppose the teleportation machine malfunctions. Suppose it scans you and transmits the information to Sydney, but fails to destroy the original. Suppose that when the process is complete, there are two of you, the original in London and the copy in Sydney. Both of you have the same memories. Both of you feel like the real you. Both of you remember stepping into the teleporter. Both of you are absolutely convinced of your own identity, but you cannot both be the same person. You are two different people, standing in two different places, about to have two different experiences. From the moment of duplication, your lives diverge. You will have different thoughts, different conversations, different meals, different dreams. You will become increasingly different with each passing moment. Which one is the real you? The obvious answer is that the original is the real you. The original has continuous existence. The original was never destroyed and recreated. The original's consciousness was never interrupted. The copy is a new person, created at the moment of teleportation, who happens to have memories of being you. But now consider what happens when the teleporter works correctly. The only difference is that the original is destroyed. The copy is exactly the same. The copy has the same relationship to the original. It is a duplicate, created from transmitted information with no continuous existence linking it to the person who stepped into the machine. The destruction of the original does not magically transform the copy into the original. It just means that there is no original anymore. The original is dead, only the copy remains. And the copy, while believing itself to be you, is a different person. This is the teleporter paradox. And it suggests that teleportation, as commonly conceived, is not transportation at all. It is killing the original and creating a copy that does not know it is a copy. Would you use such a machine? Some people say they would. They argue that what matters is psychological continuity, not physical continuity. As long as the copy has all your memories, all your personality, all your sense of being you, that is enough. The copy is you in every sense that matters. Who cares about metaphysical notions of identity? What counts is the subjective experience, and the subjective experience is preserved. I understand this view. I respect it, but I cannot share it. When I imagine stepping into a teleporter, I imagine my consciousness ending. I imagine the lights going out. I imagine death. The fact that a copy of me will wake up somewhere else, convinced that it is me, is no comfort. That copy will have its own experiences, its own future, its own life. But I will not be there to experience them. I will be gone. The copy might thank me for its existence. The copy might be grateful to live in Sydney rather than London. But I will not receive its gratitude. I will not benefit from its happiness. I will be dead. This is not irrational fear. This is a recognition that copying is not the same as moving, that duplication is not the same as transportation, that the creation of a replica does not preserve the existence of the original. Let me tell you about another thought experiment that makes this point even more vividly. Suppose we develop a different kind of teleportation technology. Instead of scanning and destroying the original, we simply create a copy at the destination while leaving the original intact. No destruction, no death, just duplication. You step into the machine. A copy of you appears in Sydney. You are still standing in London perfectly fine, watching on a screen as your copy looks around in amazement. Would you say that you have been teleported to Sydney? Would you say that you are now in Sydney? Of course not. You are in London. You can see yourself in London. The person in Sydney is someone else, a new person, a copy. Now suppose that after creating the copy, we destroy the original. We vaporize you in London. Does this change anything for the copy in Sydney? No. The copy is exactly the same either way. The copy's existence does not depend on what happens to the original after the copy is created. But from your perspective in London, everything has changed. A moment ago, you were alive, watching your copy in Sydney. Now you are dead. The copy lives on, but you do not. The destruction of the original does not transfer your consciousness to the copy. It just kills you. The copy was already a separate person before you died. Your death does not change that. This is why I say that teleportation, as conventionally conceived, is impossible. Not because we cannot scan and transmit information, not because we cannot reconstruct bodies from atoms, but because the entire concept is based on a confusion about the nature of identity. Moving a person is not the same as copying a person, and copying a person, however perfectly, does not move them. The person who steps into the teleporter dies, always, every time, without exception. The person who steps out of the teleporter is someone new. They have stolen memories of a life they did not live. They have inherited a body plan from a person they never met. They are, in the most profound sense, imposters, even though they do not know it, even though they cannot know it. This is the dark truth at the heart of the teleportation dream. It is not a dream of travel, it is a dream of death and replacement. And no amount of technological progress can change that, because the problem is not technological, the problem is conceptual. The problem is what teleportation actually means. But wait, perhaps there is another way. Perhaps there is a form of teleportation that does not involve copying and destruction. Perhaps quantum mechanics, the very theory that creates the measurement problem, also offers a solution. Let me tell you about quantum teleportation. It is a real phenomenon, experimentally demonstrated, that seems to promise exactly what we want. The transfer of quantum states without copying, without violating the no-cloning theorem, without the philosophical problems I have described. But as we will see, quantum teleportation is not what it sounds like, and it cannot save the dream of human teleportation. Let me tell you about quantum teleportation, because when people hear that physicists have achieved teleportation in the laboratory, they imagine that we are on the path to Star Trek transporters. We are not. Quantum teleportation is real. It is remarkable. It is one of the strangest phenomena ever discovered. But it is not what you think it is. And understanding why it cannot transport human beings will teach us something profound about the nature of information and reality. In 1993, a team of physicists, including Charles Bennett, proposed a protocol for transferring the quantum state of a particle from one location to another without physically moving the particle itself. The state would disappear from the original particle and appear on a different particle at a distant location. They called this quantum teleportation, and in 1997 it was experimentally demonstrated for the first time. Since then, quantum teleportation has been achieved with increasing sophistication. We have teleported the quantum states of photons, atoms, and even small molecules. We have teleported states across laboratories, across cities, from ground stations to satellites in orbit. The distances keep growing. The fidelity keeps improving. It works. But what exactly is being teleported, and why does it not help us transport human beings? To understand quantum teleportation, you need to understand a phenomenon called quantum entanglement. Einstein called it spooky action at a distance, and he meant that as a criticism. He thought entanglement was so strange that it could not possibly be real, that it must indicate some flaw in quantum mechanics. He was wrong. Entanglement is real. It has been confirmed by countless experiments. And it is indeed spooky. When two particles become entangled, their quantum states become correlated in a way that has no classical analog. Measuring one particle instantaneously affects what you will find when you measure the other, no matter how far apart they are. If you measure the spin of one entangled electron and find it pointing up, you instantly know that the other electron's spin is pointing down, not because it was always pointing down. Not because the electrons carried hidden instructions about which way to point, but because the measurement of one particle somehow determines the state of the other. This correlation is not due to any signal passing between the particles. No information travels from one to the other. The effect is instantaneous, faster than light, which would violate relativity if it could be used to send messages. But it cannot be used to send messages. The correlation is only apparent after you compare the results of both measurements, and that comparison requires classical communication at light speed or slower. Entanglement is the resource that makes quantum teleportation possible. Here is how it works, roughly speaking. Suppose Alice has a particle whose quantum state she wants to teleport to Bob. The state is unknown to her. She cannot measure it fully without destroying it because of the uncertainty principle. She cannot copy it because of the no-cloning theorem, but she can teleport it. First, Alice and Bob share a pair of entangled particles. Alice has one member of the pair, Bob has the other. These particles were prepared together and then separated. They remain entangled despite the distance between them. Alice then performs a special measurement on her original particle and her member of the entangled pair together. This measurement entangles her original particle with the entangled pair and produces a result that Alice records. Crucially, this measurement destroys the original quantum state. It is gone from Alice's particle forever. Alice then sends the result of her measurement to Bob through a classical channel, a phone call, a text message, an email. This message travels at light speed or slower. No faster than light communication occurs. When Bob receives Alice's message, he uses the information to perform an operation on his member of the entangled pair. This operation transforms his particle into an exact replica of Alice's original particle. The quantum state has been teleported. It was destroyed at Alice's location and recreated at Bob's location. This is genuine teleportation of quantum information. The state was not copied, it was moved. The no-cloning theorem was not violated because the original was destroyed in the process. The state existed at Alice's location, then it existed at Bob's location, and at no point did it exist in both places simultaneously. This sounds promising for human teleportation. If we can teleport quantum states without copying them, perhaps we can teleport people without the philosophical problems of duplication. Perhaps quantum teleportation offers a way to move the original rather than creating a copy. But there are several reasons why quantum teleportation cannot save the dream of human teleportation. The first reason is scale. Quantum teleportation has been achieved with single particles and small groups of particles. The largest systems teleported so far contain perhaps a few thousand quantum bits. A human body contains approximately 10 to the 29 atoms. Each atom contains multiple quantum degrees of freedom. The total quantum information content is on the order of 10 to the 45 bits. The gap between what we can teleport and what we would need to teleport is not a gap that will be closed by incremental progress. It is a chasm of unimaginable proportions, a difference of more than 40 orders of magnitude. The second reason is the requirement for entanglement. Quantum teleportation requires that Alice and Bob share entangled particles in advance. For every quantum bit you want to teleport, you need one entangled pair. To teleport a human body, you would need 10 to the 45 entangled pairs, distributed between the origin and destination before teleportation begins. How would you create and distribute these entangled pairs? Each pair would need to be generated, separated, and transported, one half to the origin and one half to the destination, without losing entanglement along the way. Entanglement is fragile. It is destroyed by interaction with the environment, a process called decoherence. Maintaining entanglement over long distances and long times is extraordinarily difficult. Maintaining 10 to the 45 entangled pairs simultaneously is not a practical challenge. It is a fantasy. The third reason is the requirement for classical communication. Quantum teleportation does not happen instantaneously. It requires Alice to send her measurement results to Bob through a classical channel. This communication cannot exceed the speed of light. If Alice is in London and Bob is in Sydney, the classical information must travel around the curve of the Earth, taking at least a 50th of a second. If Alice is on Earth and Bob is on Mars, the information takes between 3 and 24 minutes depending on planetary positions. Quantum teleportation is not faster than light travel. It is quantum information transfer that requires light-speed classical communication as an essential step. You cannot use it to travel to distant stars instantaneously. You cannot use it to outrun a spaceship. The speed limit of the universe remains unbroken. The fourth reason is the most fundamental, and it brings us back to the problem we started with. Quantum teleportation still destroys the original. The protocol requires Alice to perform a measurement that erases the quantum state of her original particle. The The state is transferred to Bob's particle precisely because it is destroyed at Alice's location. There is never a moment when the state exists in both places. The no-cloning theorem is satisfied because the original is annihilated. For a single particle, this is merely a technical detail. Particles have no consciousness, no identity, no subjective experience. The destruction of a quantum state and its recreation elsewhere raises no philosophical problems. For a human being, the situation is entirely different. A human being has consciousness, a human being has identity, a human being has subjective experience. And quantum teleportation would require the complete destruction of the original human being as an essential step in the process. The person in London would be annihilated. Every atom, every molecule, every quantum state that composed them would be destroyed. Their consciousness would end. Their subjective experience would cease. They would die. And then, using the classical information transmitted from London and the entangled particles waiting in Sydney, a new person would be assembled, a person with the same quantum state as the original, a person with the same memories, the same personality, the same sense of identity, a person who would be absolutely convinced that they had been teleported, that they were the same person who stepped into the machine in London. But they would not be the same person. They would be a new person, created at the moment of reassembly, with no continuous existence linking them to the person who was destroyed. The original died, the copy lives. Quantum teleportation does not change this. It merely ensures that the copy is a perfect replica at the quantum level. This is the inescapable conclusion. Whether we use classical scanning and reconstruction or quantum teleportation, the result is the same. The original is destroyed, a copy is created. The copy believes itself to be the original, but belief is not reality. The person who stepped into the machine is gone forever. Let me tell you about an additional problem that makes human teleportation even more daunting, the problem of reconstruction. Suppose we have somehow acquired the complete quantum information describing a human body. Suppose we have transmitted it to the destination. Suppose we have the entangled pairs needed for quantum teleportation, all 10 to the 45 of them, waiting and ready. Now we must reassemble the person. How do you build a human body from quantum information? A human body is not a random arrangement of atoms. It is a highly organized structure with specific architecture at every scale. Atoms form molecules. Molecules form organelles. Organelles form cells. Cells form tissues. Tissues form organs. Organs form systems. Each level of organization has specific requirements. Each component must be in the right place, with the right orientation, with the right connections to neighboring components. You cannot simply materialize atoms in a blob and expect a functioning human to emerge. You must place each atom precisely where it belongs. You must ensure that chemical bonds form correctly. You must establish the proper three-dimensional structure of every protein, every membrane, every cellular component. You must do this for trillions of cells simultaneously, and you must do it instantly. A human body is not a static structure. It is a dynamic system in constant motion. Blood is flowing, neurons are firing, enzymes are catalyzing reactions. If you assemble a person too slowly, the early parts will begin to decay before the later parts are complete. You will end up with a corpse, not a living person. The assembly process would need to happen in a time shorter than the relevant biological timescales. Nerve impulses travel at about 100 meters per second. Enzyme reactions occur in microseconds to milliseconds. Blood flow is continuous. To assemble a living, functioning human body, you would need to place 10 to the 29 atoms in their correct positions in something like a millisecond. That is 10 to the 32 atoms per second. There is no known physical process that could accomplish this. But let us imagine that somehow we solve this problem too. Let us imagine that we have some miraculous assembly technology that can construct a human body from quantum information in the required time. Let us imagine that every technical obstacle has been overcome. We are still left with the fundamental problem. The person who is assembled is not the person who is disassembled. They are a copy, a replica, a new creation with old memories. The original is dead. The thread of consciousness has been cut and a new thread has begun. Some philosophers argue that this does not matter. They argue that personal identity is not about physical continuity, but about psychological continuity. If the copy has all the memories, all the personality, all the psychological characteristics of the original, then the copy is the original in every sense that matters. The physical substrate is irrelevant. What matters is the pattern, and the pattern is preserved. I find this view difficult to accept. Let me tell you why. Imagine that instead of teleportation, we developed a different technology, a technology that creates a perfect copy of you while leaving the original intact. No destruction, no death, just duplication. You step into the machine, a copy of you appears in the next room, you walk around the machine and meet your copy, you shake hands, you compare memories, you are identical in every way. According to the psychological continuity view, both of you are equally you. Both of you have psychological continuity with the person who stepped into the machine. Both of you have equal claim to your identity. But this seems absurd. You know that you are you. You know that the copy is someone else. The copy has your memories, but the copy did not live your life. The copy has your personality, but the copy was created 5 minutes ago. You have continuous existence stretching back to your birth. The copy has existence stretching back 5 minutes. The psychological continuity view cannot distinguish between you and the copy, but you can distinguish. You know which one you are, and that knowledge is not based on psychology. It is based on the brute fact of physical continuity, on the unbroken chain of existence that connects your present self to your past self. Now suppose that after meeting your copy, we destroy you and keep the copy. Has anything changed for the copy? No. The copy is exactly the same. The copy still has your memories, your personality, your sense of identity, but something has changed for you. You are dead. The destruction of the original does not transfer your consciousness to the copy. It just ends your consciousness. The copy continues, oblivious, convinced that it is you, but you are gone. This is what teleportation would be, every time, without exception. Let me tell you about the no-cloning theorem, because this principle lies at the heart of why teleportation is fundamentally different from any other form of transportation, and why the philosophical problems I have described cannot be circumvented by clever engineering. The no-cloning theorem was discovered in 1982 by William Wouters and Wojciech Zurek, and independently by Dennis Dieks. It states something that sounds almost trivially obvious, but has profound implications. You cannot create an exact copy of an arbitrary, unknown quantum state. In classical physics, copying is easy. If you have a document, you can photocopy it. If you have a file, you can duplicate it. If you have a pattern of any kind, you can measure it and recreate it elsewhere. The copy might not be perfect due to practical limitations, but there is no fundamental obstacle to copying classical information. Quantum mechanics is different. A quantum state cannot be copied without destroying the original. This is not a technological limitation. This is not a matter of insufficient precision or inadequate equipment. This is a fundamental law of nature, as inviolable as conservation of energy or the speed of light limit. The proof is surprisingly simple. It follows from the linearity of quantum mechanics, from the basic mathematical structure of the theory. If you could build a device that copied arbitrary quantum states, you could use it to send information faster than light. You could violate the uncertainty principle. You could break the foundations of physics. Since these things are impossible, cloning must be impossible too. This theorem has enormous implications for teleportation. If you want to teleport a person, you need to transfer their complete quantum state from one location to another. But you cannot simply measure the quantum state, record it classically, and recreate it elsewhere. Measurement disturbs quantum states. The act of extracting the information destroys the information you are trying to extract. You cannot read and copy quantum information the way you can read and copy classical information. Quantum teleportation, the protocol I described earlier, gets around this limitation through a clever trick involving entanglement. But even quantum teleportation does not copy the state. It transfers the state by destroying the original. The no-cloning theorem is satisfied precisely because the original is annihilated. This means that any form of teleportation that preserves quantum information must destroy the original. There is no way around this. There is no alternative protocol waiting to be discovered that transfers quantum states without destroying them. The mathematics forbids it. Some science fiction stories imagine teleportation that keeps the original intact, creating copies without destruction. The no-cloning theorem says this is impossible. You cannot have both the original and the copy. If you try to make a copy, you must destroy the original. If you keep the original, you cannot make an exact copy. This might seem like good news for personal identity. If you cannot have both the original and the copy, perhaps the copy really is the original, just relocated. Perhaps the transfer is genuine transportation, not duplication. But this reasoning is flawed. The no-cloning theorem tells us about what is possible and impossible within quantum mechanics. It does not tell us about the metaphysics of personal identity. It does not tell us whether consciousness survives the destruction and recreation of its physical substrate. Let me put it another way. The no-cloning theorem guarantees that after teleportation there will be only one copy of you, but it does not guarantee that this copy is you. It does not guarantee that your consciousness, your subjective experience, your inner life has been transported rather than extinguished. The physics ensures uniqueness. It does not ensure survival. Consider an analogy. Suppose I have a candle burning in London. I want to teleport the flame to Sydney. I extinguish the candle in London, destroying the original flame. At the same moment, I light a new candle in Sydney using a match. The flame in Sydney has the same temperature, the same color, the same chemical composition as the flame in London. Is it the same flame? Most people would say no. The original flame was extinguished. The new flame is a different flame, even though it has the same properties. Flames do not have identity in the way persons do, but even for flames, we recognize that destruction and recreation is not the same as transportation. Now consider the candle flame more carefully. A flame is not a thing, it is a process. It is a pattern of chemical reactions, a dynamic system sustained by continuous combustion. The molecules in a flame are constantly changing. The flame persists as a pattern, while its physical constituents are replaced. This sounds like the argument for psychological continuity. Persons are patterns too. The atoms in your body are constantly replaced. If the flame is not the same flame after being extinguished and relit, why should a person be the same person after being disassembled and reassembled? Or consider a different analogy. Suppose I have a complex sandcastle on a beach in Cornwall. I want to move it to a beach in California. I carefully measure every grain of sand, recording its position with perfect precision. Then I destroy the sandcastle, ship the information to California, and reassemble an identical sandcastle on the new beach using local sand. Is it the same sandcastle? In one sense, yes. It has the same structure, the same pattern, the same form. In another sense, no. The original sandcastle was destroyed. The new sandcastle is a copy, made from different sand on a different beach. It is a replica, not the original. Most people would say the sandcastle was not moved but copied. The original was destroyed. A duplicate was created. The information was transmitted, but the sandcastle itself was annihilated. But persons are more like flames than sandcastles, some might argue. Persons are processes, not static structures. The pattern is what matters, not the physical substrate. I am not entirely convinced by this argument, but let me accept it for the sake of discussion. Let me grant that what makes you you is the pattern, not the atoms. Let me grant that the atoms are irrelevant, that identity is constituted by information rather than matter. Even so, there is a problem, the problem of continuity. When your atoms are replaced through metabolism, there is continuous physical existence. The pattern is maintained throughout the replacement process. At no point does the pattern cease to exist. There is no gap, no interruption, no moment of non-existence. Teleportation is different. In teleportation, the original pattern is destroyed before the new pattern is created. There is a gap, a discontinuity, a moment when the pattern exists nowhere. The original is gone, and the copy does not yet exist. This gap might be very brief. It might be microseconds or nanoseconds. It might, in principle, be made arbitrarily short, but it cannot be eliminated entirely. The physics requires that the original be destroyed as part of the information extraction process. There must be a moment when you are gone. And then a new pattern appears, a pattern identical to the one that was destroyed. But is it the same pattern or a different pattern with the same structure? Consider the ship of Theseus, the ancient thought experiment. A ship is gradually repaired plank by plank until every original plank has been replaced. Is it still the same ship? Most people have the intuition that gradual replacement preserves identity. The ship remains the same ship throughout the process, even though none of the original material remains at the end. But now suppose that instead of gradual replacement, you destroy the ship entirely and build an exact replica from new wood. Is the replica the same ship? Most people have the intuition that this is not the same ship. The replica is a copy, not the original. The original was destroyed. What is the difference between the two cases? The pattern is preserved in both cases. The material is replaced in both cases. The difference is continuity. In the first case, the ship exists continuously throughout the replacement process. In the second case, there is a gap, a moment when the ship does not exist, followed by the creation of a new ship with the same design. Teleportation is like the second case, not the first. There is a gap. The original is destroyed. A copy is created. The copy is not the original, even though it has the same pattern, even though it has the same structure, even though it has all the same properties. Let me tell you about another thought experiment that clarifies what is at stake. Suppose you are told that tonight, while you sleep, your body will be teleported to another location. You will be scanned, disassembled, transmitted, and reassembled. When you wake up, you will be in a beautiful tropical paradise instead of your ordinary bedroom. Would you go to sleep peacefully, looking forward to waking up in paradise? Now suppose you are told something slightly different. Tonight, while you sleep, you will be painlessly killed. Your body will be destroyed. At the same moment, a perfect copy of you will be created in a tropical paradise. The copy will wake up with all your memories, believing that it is you, believing that it had a wonderful night's sleep and has now arrived in paradise. Would you go to sleep peacefully? I suspect your reaction to these two scenarios is very different, even though they describe exactly the same physical process. The first scenario is described as teleportation. The second is described as death followed by copying. But they are the same thing. The difference is framing. The word teleportation makes it sound like transportation. The words death and copying make it sound like what it actually is, the end of your existence and the creation of a replica. Your intuitions about the two scenarios reveal something important. You know, at some level, that teleportation is not really transportation. You know that being destroyed and copied is not the same as being moved. You know that the person who wakes up in paradise is not you, even though that person will believe it is you, even though that person will have all your memories, even though that person will be absolutely convinced of continuous existence. This is not a rational fear of new technology. This is a correct understanding of what teleportation actually means. Let me tell you about one more problem with teleportation, a problem that is often overlooked but is perhaps the most troubling of all, the problem of experience. What would it be like to be teleported? What would you experience during the process? If my analysis is correct, you would experience nothing. Your consciousness would end at the moment of scanning. Your subjective experience would cease. The lights would go out. There would be no tunnel of light, no sensation of movement, no dreamlike transition from one place to another. There would be nothing because you would no longer exist. The person who appears at the destination would have a different experience. That person would open their eyes, look around, and feel as though they had just arrived after a brief moment of unconsciousness. They might feel a slight discontinuity, like the jump between falling asleep and waking up. Or they might feel nothing unusual at all, just a smooth transition from one location to another. But this experience belongs to the copy, not to you. You do not get to have this experience. You do not get to wake up in the new location. You do not get to feel the tropical breeze or see the beautiful sunset. Your experiences ended in the teleporter chamber. What happens after that happens to someone else. This is the subjective horror of teleportation. From the outside, it looks like transportation, A person goes in, a person comes out. Continuous existence appears to be preserved. But from the inside, from the perspective of the person being teleported, it is death. It is the end of everything. It is the permanent cessation of consciousness. The copy does not know this. The copy feels fine. The copy has no sense of having died and been replaced. The copy's memories are continuous with the original's memories. The copy experiences no interruption, no gap, no sense of being new. But the copy's experience does not tell us what happened to the original. The copy's experience is the copy's experience. The original's experience ended. This asymmetry is the heart of the problem. Teleportation looks benign from the outside and from the perspective of the copy. It is only from the perspective of the original that the true nature of the process is revealed. And the original is not around to tell us what they experienced because the original is dead. Some philosophers argue that this concern is misguided. They argue that there is no fact of the matter about whether the copy is the same person as the original. Personal identity, they say, is not a deep metaphysical fact, but a convenient fiction, a way of talking that works well enough in ordinary circumstances, but breaks down in edge cases like teleportation. Perhaps they are right. Perhaps personal identity is an illusion, a story we tell ourselves about the continuity of self that has no basis in ultimate reality. Perhaps the Buddha was right that there is no self, no persistent entity that travels through time, only a succession of momentary experiences that we mistakenly unify into a continuous narrative. If this is true, then teleportation is no worse than ordinary existence. Every moment, the self of the previous moment ceases to exist, and a new self takes its place. We are all being destroyed and replaced constantly. Teleportation just makes it more obvious. But I am not sure I can live by this philosophy even if it is true. I am not sure I can step into a teleporter with equanimity, knowing that my consciousness will end and be replaced by a copy's consciousness. The intellectual argument may be sound, but my survival instincts rebel against it. And perhaps those instincts are telling me something important. Perhaps the feeling that death is bad, that I want to continue existing, that I do not want to be replaced by a copy, is not mere confusion, but genuine wisdom. Perhaps personal identity, even if philosophically problematic, is real enough to matter. Now, let me tell you about the physics of what you actually are, because I think this reveals something profound about why teleportation is not just technically impossible, but conceptually misguided. And I think it reveals something beautiful about the nature of existence that we should not want to escape, even if we could. You are not a thing. You are a process. This sounds like a philosophical statement, but it is a physical fact. At every level of description, from the subatomic to the cellular to the organismal, you are not a static object, but a dynamic pattern, a continuous flow of matter and energy maintaining itself against the relentless tide of entropy. Consider what happens in your body at this very moment. Your heart is beating, pushing blood through 100,000 kilometers of blood vessels. Your lungs are exchanging gases, bringing in oxygen and expelling carbon dioxide. Your digestive system is breaking down food, extracting nutrients, eliminating waste. Your immune system is fighting off pathogens, identifying threats, maintaining the boundary between self and not self. Your cells are dividing, dying, being replaced. Your neurons are firing, forming new connections, pruning old ones. Proteins are being synthesized, folded, transported, degraded. Enzymes are catalyzing reactions at rates of thousands per second. ATP is being produced and consumed, the molecular currency of life being spent and replenished in an endless cycle. You are not a thing that does these processes. You are these processes. Take them away and you do not exist. You are the pattern of activity, not the matter in which the activity occurs. This is what makes you different from a rock or a chair or a computer. A rock is a static arrangement of atoms. You can move a rock from one place to another and it remains the same rock. The atoms stay in the same relative positions. The structure is preserved. A person cannot be moved in this way because a person is not a static structure. A person is a dynamic system, a flame rather than a stone, a river rather than a pond. The pattern persists through continuous activity. Stop the activity, and the pattern dies. This is why the analogy between teleportation and ordinary transportation breaks down. When you move a rock, you are moving a static thing from one place to another. The rock exists at the starting location, travels through space, and exists at the destination. There is continuous existence throughout the journey. When you teleport a person, you are not moving a thing. You are destroying a process at one location and initiating a new process at another location. The original process ends, the new process begins. There is no continuous existence, no journey through space, no thing that travels from here to there. The copy in Sydney is not the person from London who has been moved. The copy is a new process, initiated from a blueprint, beginning its existence at the moment of assembly. The original process ended in London. It did not travel to Sydney. It ceased. This is why I say that teleportation is impossible for humans. Not because we cannot scan and transmit information, not because we cannot reconstruct bodies from atoms, but because humans are not the kind of thing that can be teleported. Humans are processes, and processes cannot be moved by copying. They can only be ended and replaced. Let me tell you about what physics reveals about the continuity of existence, because I think this is where the deepest insights lie. In physics, we describe the evolution of systems through time using equations of motion. These equations tell us how a system changes from one moment to the next. They describe continuous trajectories through the space of possible states. For a classical system, like a ball rolling down a hill, the trajectory is deterministic and continuous. The ball is at one position, then at a slightly different position, then at another, tracing a smooth path through space and time. There is no discontinuity, no gap, no moment when the ball ceases to exist and then reappears. For a quantum system, the situation is more subtle, but continuity is still preserved in a deep sense. The quantum state evolves according to the Schrödinger equation, a continuous, deterministic evolution of the wave function. Measurement introduces apparent discontinuities, the famous quantum jumps, but even these can be understood as continuous processes when the measurement apparatus is included in the quantum description. The point is that physics describes continuous evolution. Systems change through time, but they do not pop out of existence at one location and pop into existence at another. Conservation laws, the fundamental principles that govern what can and cannot happen, forbid this. Energy cannot be created or destroyed. Momentum cannot be created or destroyed. Information, in the quantum sense, cannot be created or destroyed. Teleportation, as commonly imagined, violates this continuity. A person exists in London, then does not exist anywhere, then exists in Sydney. There is a gap in the trajectory, a discontinuity in the evolution of the system. From the perspective of fundamental physics, something has gone badly wrong. Quantum teleportation, as I explained, gets around this by using entanglement and classical communication. But even quantum teleportation does not create discontinuity in the physics. The quantum information is transferred through a continuous process involving both quantum and classical channels. There is no moment when the information exists nowhere. But here is the crucial point. Even though the quantum information is transferred continuously, the physical system that embodies that information is not. The original particle in London is destroyed. A new particle in Sydney receives the quantum state. The information is continuous, the physical embodiment is not. For particles, this distinction may not matter. Particles have no identity beyond their quantum states. An electron is an electron is an electron. If you transfer the quantum state from one electron to another, you have transferred everything there is to transfer. For persons, the situation is different. A person is not just a quantum state. A person is a physical system, a body, a brain, a living organism embedded in an environment. A person has a history, a trajectory through space-time, a continuous existence that began at birth and will end at death. Transferring the quantum state of a person to a new body is not the same as moving the person. It is creating a new person with the same quantum state. The new person has no history before the moment of creation. The new person did not exist yesterday or last year or at birth. The new person began existing at the moment of reassembly. The original person, by contrast, has a history, a continuous trajectory through space-time stretching back to birth, a life lived, experiences had, memories formed. This history ends at the moment of scanning. It does not continue in Sydney. It terminates in London. The copy in Sydney inherits the memories of this history. The copy knows about the original's childhood, the original's first kiss, the original's proudest achievements. But the copy did not live this history. The copy was not there. The copy is like someone who has read a very detailed autobiography and mistaken it for their own life. This is the sense in which teleportation is impossible. It is not that we cannot transfer information. We can, at least in principle. It is that transferring information is not the same as moving a person. A person is not just information. A person is an ongoing process with a history, and you cannot move a history by copying it. Let me tell you about why I think this matters, beyond the practical question of whether teleportation will ever be built. The dream of teleportation is, at its heart, a dream of escape. Escape from the limitations of physical existence, escape from distance, from time, from the slow crawl of matter through space. We imagine teleportation as liberation, as transcendence, as freedom from the constraints that bind us to our bodies and our locations. But I think this dream rests on a misunderstanding. It rests on the idea that you are separate from your body, that there is a you that could be extracted from your physical form and transmitted elsewhere like a message, like a file, like pure information without material substrate. This idea is very old. It is the idea of the soul, the immaterial essence that animates the body and survives its death. It is the idea of the ghost in the machine, the homunculus inside your head that is the real you, while your body is merely a vehicle. Physics does not support this idea. There is no ghost in the machine. There is only the machine, and the machine is not a machine at all, but a living process, a pattern of activity, a flame that burns for a while and then goes out. You are not separate from your body. You are your body. You are not information encoded in matter. You are the matter, doing what matter does when it is arranged in the fantastically complex configuration that constitutes a human being. This is not a limitation. This is what it means to exist, to be something rather than nothing, to be here rather than everywhere, to be now rather than always, to be you rather than everyone. The dream of teleportation is a dream of being liberated from these constraints. But I think the constraints are not shackles. They are the very conditions of existence. Without them, there would be no you to be liberated. Let me tell you about what I find beautiful in the impossibility of teleportation. The fact that you cannot be copied means that you are unique. Not unique in your pattern, which could in principle be duplicated, but unique in your existence. There is only one you. There has only ever been one you. There will only ever be one you. The fact that you cannot be teleported means that your journey through space and time is real. When you travel from London to Sydney, you actually traverse the intervening distance. You exist at every point along the way. Your history is a continuous line, not a series of disconnected points. The fact that you cannot escape your body means that your experiences are genuinely yours. When you see a sunset or taste a meal or feel the touch of someone you love, you are not downloading data into a detachable soul. You are living, in the only way that living is possible, as an embodied being in a physical world. These constraints make life precious. If you could be copied, you would be replaceable. If you could be teleported, your existence would be fragmented. If you could escape your body, your experiences would be disembodied abstractions rather than lived realities. I do not mourn the impossibility of teleportation. I celebrate it. It means that I am real, that my life is real, that my experiences are genuinely mine. It means that when I die, something unique will be lost, not because my pattern cannot be duplicated, but because I am more than my pattern. I am a history, a trajectory, a process that began and will end. And in the meantime, I am here, in this body, in this place, in this moment. Not as information waiting to be transmitted, but as a living being, experiencing the universe from this particular point of view, irreplaceable and unrepeatable. This is the human condition. We are bound to our bodies, to our locations, to the slow passage of time. We cannot be teleported or copied or uploaded. We are stuck with the constraints of physical existence. But these constraints are not a prison. They are the architecture of meaning. They are what makes your life yours, what makes your experiences real, what makes you you. The universe is vast beyond comprehension. Billions of galaxies, trillions of stars, distances so immense that light itself takes billions of years to cross them. We will never see most of this universe. We will never visit the distant galaxies that our telescopes reveal. We are confined to this tiny corner of the cosmos, this pale blue dot, this brief moment in the 14 billion year history of everything. And yet, here we are. Conscious beings, aware of ourselves and our universe, capable of asking questions about the nature of existence and the limits of the possible. We may not be able to teleport to distant stars, but we can send our thoughts there. We can imagine what it would be like. We can understand in some small way the vast cosmic drama of which we are a part. This is enough. This is more than enough. This is miraculous. Teleportation would be convenient. It would save time and reduce carbon emissions and transform the economy and revolutionize human civilization. But it would also, in a deep sense, be a kind of death. The death of continuous existence. The death of embodied experience. The death of the historical, trajectory-following, process being that is a human person. I would rather live as a process than be transmitted as information. I would rather traverse the distance than skip over it. I would rather be bound to my body than be liberated from existence itself. The impossibility of teleportation is not a failure of physics. It is a revelation about what we are. We are not information. We are not patterns. We are not software running on biological hardware. We are processes, flames, rivers, songs. We exist in time, through time, as time. We cannot be paused or copied or transmitted because we are not static things but dynamic becomings. And this, I think, is wonderful. Not a limitation to be overcome, but a truth to be celebrated. The truth of what it means to be alive, to be here, to be now, to be you. The laws of physics that make teleportation impossible are the same laws that make you possible. The constraints that bind you to your body are the same constraints that give your existence meaning. The impossibility of escape is the possibility of presence. You are here, you are now, you are you, and there is nowhere else you need to be.